Good day and welcome to the Math Salon. My name is Dr. Numendem. So we're looking at 3 paper 1 questions for the advanced levels. So the first question says, the binomial expansion this is valid for which values of x? So it says it's valid for which range of values of x? So what we expect here is that we have our square root of 1 minus 3x divided by 4 minus 3x. We've learned in the past that the binomial expansion is usually of the form this, and can you open to give all the terms that are required from this expansion. Normally that is easy when n here is a positive integer. When n is not a positive integer, then this would only be binomial expansion condition on the x, then that will only hold if this is the case. So if this is not a positive integer, then this is only valid as binomial expansion if this here, the absolute value is less than 1. So normally this would be written as 1 minus 3x raised to the power half divided by 4 minus 3x. The square root is also as the power half. I would like to fix this to look a little like that. If that is the case, then I will write this as 1 plus the brackets minus 3x raised to the power half on 4 minus 3x. If that is the case, I have no problem with the denominator. This is not any expansion, so it's only the numerator. So, and I see my n is not a positive integer. So if that is the case, then I have to check on that one. That means the magnitude of 3x here should be less than 1. This actually means minus 3x should be greater than minus 1, less than 1. I can divide both sides by minus 3. But watch out, when you divide by minus, when you have an inequality, the direction of the inequality will change. So that means this will be minus 1 on minus 3 greater than x greater than 1 on minus 3. So x is simply bigger than minus 1/3, less than 1/3. Those are the range of values for which this expansion is valid as a binomial expansion. The next question says, find the third term in the series this. So let me rewrite my series here. The summation symbol, the sum, r, which is equal to minus 6 to 0 of 1 divided by r into r to r plus 1. This series expansion, if you try to write them, you see the first term is when r is equal to minus 6. So first term, r is equal to minus 6. Second term, r is equal to minus 5. Third term, r is equal to minus 4. So the third term would be when r is equal to minus 4. So I will just use minus 4 in this part here. So in that case, I have 1 divided by minus 4 into brackets 2 times minus 4 plus 1, and that is 1 divided by minus 4 in the bracket. 2 times minus 4 is minus 8. Minus 8 plus 1 is minus 7. Minus 7 times 4 is 28. The minuses become positive. So that is 1 on 28. So that's the third term in that series. Question number 3 says, what is dy dx given that y is equal to cos theta and x is equal to theta plus sin theta? Once again, we are to look for a derivative. We've already done a number of them in some of our videos. It's good you can check back to them and make sure that you have all what is required for any question that can come in the future. So in that case, we say when you have your y and x given in all the parameters, then we have to apply our chain rule there. So we say we can write dy dx as dy d theta times d theta dx, which is dy d theta divided by dx d theta. So I chose this form here. I just put d theta, so you can cancel and you see that it's the same thing there. Then here I decided to put a division so I can swap the denominator and get the dx d theta. So what I'm just left to do is look for this and look for that, and I substitute here. So y is given like this, so that means my dy d theta here is equal to minus sine theta that is the derivative of cos theta. And here, my x is given as that, so my dx, d theta is 1 here, plus, this is, the derivative of sin theta is cos theta. So we are just left to put into our formula here. So dy, d theta, that is that, minus sin theta, divided by dx d theta, that is 1 plus cos theta. And that was it. Hope you liked it, and if you did, please remember to subscribe and share with your friends.